Ladies and gentlemen, here we are doing definite integrals yet again. Hopefully you remember that we have done these before, but we're going to have a slightly different twist this time, with the emphasis being practice on some of the concepts that we know already. Now let's kind of remind ourselves what this is asking for. The integral from 1 to 3 of x squared plus 1 is really saying consider the graph of x squared plus 1, and then look at x equals 1, look at x equals 3, and you're finding the area under the curve between these two x values, right? And that's what the answer to your definite integral will be, the integral with these two endpoints. Now, we've kind of practiced some methods of approximation before, maybe with your calculator, maybe with rectangles, but the way we need to be doing it here, and the way you can actually be forced to do it, so you need practice with it, is by actually doing the antiderivative that we have learned in Chapter 7. So specifically, what I mean by that is start by just taking the antiderivative of x squared plus 1 dx. Now, if you've had enough practice from the first two sections, you'll remember that this is x cubed over 3 plus x. Now, with a definite integral, we are not done yet. So remember these bounds that I didn't write down. 1 and 3, what do we do with those? So what I want you to think about is I'm going to write it over here, and basically the way this is going to work is I'm going to plug in 3 into this equation here. So at x equals 3, my equation is 3 cubed over 3 plus 3. I'm also going to plug in 1, x equals 1, so I'll have 1 cubed over 3 plus 1. And I'm going to take the difference of these two values. So this is really going to be 12 minus 4/3. And if you work that out in your calculator, you'll see that you have 32/3. Now, it's really important that you do it this way, because it's really easy to write test questions that force you to do it this way. And so, as you can see, this is really basically all we're going to be doing this section. And so it's just practice on techniques we've learned already. I'll remind you of a few more, and then I'll let you get on your way. But if you're having trouble, definitely go back and look at probably the u substitution section is going to be the most important one for you. So let's see this example here, the integral from 1 to 3 of that mess, right? So we start by just doing the regular antiderivative. X squared plus 2 to the 4th dx. And so you'll notice that we don't have a formula for this one, right? And so that means the only other method we know at this point is u substitution. And our inner function here is going to be the one that's underneath the power. This will be my u, right? So I'll have u is equal to x squared plus 2. du over dx will be equal to 2x, which will mean in turn that dx is equal to du over 2x. Now, I'm going to take these two things, I'm going to substitute them into my integral. I'm still following that 5-step process that we learned in the last section, I'm just not writing them down explicitly. 1, 2, 3. I'm going to substitute them in, and I will see that we have x times u to the 4th, and then I'll have du over 2x. Now, to simplify this, I'll notice that my x's cancel. I have a 2 on the bottom that I'm able to pull out, and I'll have 1/2 integral u to the 4th du. My fourth step here will be actually do the integral, so I'll have 1/2 u to the 5th over 5. And this is kind of where it cuts off. We don't really need to do the plus c anymore because it's a definite integral. All right, so we're going to plug back in our, I can leave the plus c there for now. I'll plug back in my x values, which is what I'm interested in. Let me draw a dividing line there. So u is equal to x squared plus 2, and we'll have 1/2 x squared plus 2 to the 5th over 5 plus c. Okay, so now back to the definite integral part. We'll have my x equals 3, which would be 1/2, times 3 squared plus 2 to the 5th over 5 plus c. It's my x equals 3. And at x equals 1, I have 1/2 times 1 squared plus 2 over 5. This is all to the 5th here. And that's also plus c. If you go through and type this mess into your calculator, you'll find that you have 16105.1 minus 24.3 for a final answer of 1680.8. Okay, so it's a little bit messier here, but the two big steps are find integral, or find the antiderivative would be a better way to say it, and then plug in the top value, plug in the bottom value, and subtract. Okay, so these are the two big steps we'll follow in any problem, and I'll just do a few simple ones here, just kind of as a quick refresher. You probably don't necessarily need to watch these. If you had the integral from 2 to 5 of 4 over x squared, the way this would be done is you would have 4 integral 2 to 5 x to the negative 2 dx. That'll be 4 x to the negative 1 over negative 1 from x equals 5 to x equals 2. You plug in x equals 5 and you'll get negative 4 over 5. If you do that in your calculator, plug in x equals 2 and you'll get negative 4 over 2. So we'll have negative 8 plus negative 0.8 plus 2, which is 1.2. Next one. This is kind of looks like a tricky one, but it's actually not too bad. 1 over the square root is x to the negative 1/2 dx, and you'll just want to use your n rule here. So we'll have x to the 1/2 over 1/2 from x equals 4 to x equals 2. Probably want to simplify this as 2x to the 1/2. And from there you'll get 2 times root 4 minus 2 times root 2. You can type that in your calculator to get an approximation. This will be 4 minus 2 root 2, and that is 1.716. Bad looking 6 there, though. Last one, 1 over x. This antiderivative is just going to be the ln, the absolute value of x. And we're going from x equals 3 to x equals 1. So we'll have the ln of 3 minus the ln of 1. The ln of 1 is 0, remember, so this is really just the ln of 3. If you type that into your calculator, you will get 1.0986. Okay, so just a few simple reminders there, but big idea was these two steps. Find the antiderivative, plug in the bottom, top, plug in the bottom, and subtract.